Hello, in this video I'm going to introduce three categories of functions. They are the exponential functions, logarithmic, and quadratic functions. So let's start with the exponential functions. So an exponential function has a form of y equals b to the x. So this is the most basic form, and I'll actually show some variations on this in a minute. So the b here can be any non-negative number and greater than 1, and or not equal to 1. So to get an idea of what the behavior of this function, I'm going to start with a table. Pick a value for b, construct a table of values, and then plot points, and then see if I can get an idea of what the graph and overall behavior of this function is. So let's start with y equals 2 to the x. So this would be an exponential function with base 2. So b there is for base. That's the base of the exponential. And I'm going to construct my table with x values and y values. And let's see, I'm going to just start with 0, 1, 2, and then we'll just go up to 3. So when I replace the x with a 0, that's 2 to a power of 0. Anything raised to a power of 0 is just 1. Next, I'm going to plug in 1, so that's 2 to the first power. Anything to a power of 1 is itself, so that's 2. When I replace the x with 2, that just is a square, so 2 squared, 2 times itself is 4. And then 2 cubed is 2 times 2 times 2, which is 8. So let's sketch behavior here. I'm going to make some marks. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And plot some points. So the first order pair I have is 0, 1. So there's a point here. Next I have 1, 2, and then 2, 4, and finally 3, 8. So it looks like what's happening is that this is growing, and it grows faster and faster as my values of x increase. So this would keep going, it gets very steep. Now if you're curious about what happens on the other side of the y-axis, this starts decreasing and actually gets closer and closer and closer to the x-axis. But it never touches the x-axis nor goes below it. So this is the basic shape of any exponential function. It's a curve, and it at some point is going to start increasing very rapidly. All right, so let's look at a logarithmic function. So a log function is what we call on math an inverse function of an exponential. So the way that we write this, y equals, and we can abbreviate logarithmic as log. A log function also has a base. We write it as a subscript. The log base b, and then our variable x is inside the log function. So what this means is we're saying b to some power, that's our y value, gives us this, will give us this value of x. So again, to see the behavior of a log function, I'm going to construct a table of values. We're going to have to pick a base, and let's just stick with 2. So our function is going to be y equals the log base 2 of x. And keeping in mind that I'm asking myself, 2 raised to some power will give me this result, the x value. So I'm going to pick some values of x. Well, let's go with 1, 2, 4, and 8. I'm being strategic in picking these values for x, and I think you'll see why in just a moment. So the first thing I want to ask myself is 2 raised to some power equals 1. So let's see what I need to put here to make this a true statement. Well, as we discussed earlier with the exponential function, anything raised to a power of 0 is just 1. So this would be 0. To what power do I raise 2 to get the result of 2? So in order for this to be a true statement, I would have to put a 1 in this position. 2 to the first power is 2. And next, to what power would I raise 2 to get a result of 4? I would square 2 in order to get 4, so this must be 2. And then lastly, to what power do I raise 2 in order to get 8? We saw before that you would cube 2. 2 times 2 times 2 equals 8. So now let's look at the graph of this logarithmic function with base 2. So I'll add some markers here. 1, 2, 3, 4, 5, 6, 7, and 8. And 1, 2, 3, 4, 5. Let's add some points. So the first order pair is 1, 0. So there's a point here on the x-axis. Next I have the point 2, 1. And the order pair 4, 1, 2, 3, 4, 2. And then I need to jump over to 8, and then I'll have a y-coordinate 3. 1, 2, 3, 4, 5, 6, 7, 8. And I'll go up 3 positions here. So this is also a curve. It's actually just increasing. So it's going up, and then it starts to flatten out. Now it still is going up and up and up. It's just at a very slow rate. And if you're curious about what happens over here, this goes below the x-axis and gets closer and closer and closer to the y-axis, but never touches. That starts going down very rapidly. So this is y equals the log base 2 of x. And now let's look at our quadratic functions. So quadratic. A quadratic function is going to have the form y equals ax squared plus bx plus c. And each of these values, a, b, and c, will play a role in the shape and position of this quadratic. But I want to just do the simplest quadratic, y equals x squared. So in this version, the value for a is 1, and b and c are both 0. And let's make a table of values for y and x. And let's go -3, -2, -1, 0, 1, 2, and 3. So for the y value, I'll just square each of these. -3 times itself is 9. -2 times itself is 4. This is 1, 0, 1. 2 squared is 4. 3 squared is 9. And let's look at the graph of this basic quadratic function. One, 2, 3, 4, 5, 6. I maybe should have moved this down a little bit more, but 1, 2, 3, 4. 1, 2, 3, and 4. So let's plot some points. I'm going to start in the middle. I have the order pairs 0, 0, so that's here at the origin. Moving down, I have the point 1, 1, so over 1 and up 1. This is over 2 and up 1, 2, 3, 4, and 3, and that's going to be somewhere here off the charts. Let's go back in the negative numbers. -1 also has a y-coordinate of 1. -2, 4. So we see this shape that we call a parabola. And you could play around with the values of A, B, and C. If we change the value of C, that can actually move the parabola up and down. For instance, the value of A, if it were negative, it could actually flip the parabola so that we say that it opens down. So changing these values can manipulate the shape of the quadratic, But basically, it's going to be some sort of a U shape. Sometimes it may be, a wider U. Sometimes it may be a skinnier U. It may be moved. So switch colors. By adjusting these values, it's also possible to just move it, so that it's not based at the origin. By the way, this point is called the vertex. That's the low point, in this case when it's opening up. So that's where the curve changes, is at the vertex of the parabola. So that's the overall shape, and the vertex is just this point. So those are the three categories of functions that we're going to be looking at in this series of videos.